Ladies and gentlemen, welcome to another episode of the Question Bank. Today we have a question from all of our favorite chapters. You're right, biochemistry. I'm joking, I know some of you find it very hard, but hopefully we're gonna make this easy. Alright? So let's see what question we have here today. We have a 5-month-old boy who's diagnosed with a rare genetic disorder involving abnormalities in endochondral bone formation. Genetic mutations are identified in a gene coding for a protein that is involved in the movement of vesicles into the Golgi complex. Which of the following features is most likely present on an electron microscopy of this patient's cells? So, what do we do first with our questions? We look at our demographic. We have a 5-month-old boy. So, relatively young patient here. We're into pediatrics. Who has a rare genetic disorder involving abnormalities in endochondral bone formation. Now, we can think of a whole wide array of different conditions here. It can be autosomal dominant, it can be autosomal recessive, it can be anything, right? Let's see if they've given us further information. So, the mutation is in a gene coding for a protein that is involved in movement of vesicles into the Golgi complex. This is the heart of the question, this sentence. If you understand this sentence, you can get your answer. Why is the sentence important? The mutation is involved in a protein that is involved in the movement of vesicles into the Golgi complex. Now, this is specifically asking, do you know which protein moves vesicles into the Golgi complex? Let's take an approach to this. If we have to think about proteins, okay, we have proteins, they are synthesized in ribosomes. Now we have two types of ribosomes. We have free and we have attached. Now where are the attached ribosomes? Okay, the attached ribosomes are found in the rough endoplasmic reticulum. Okay, the free ribosomes are floating in the cytoplasm, right? So, what is the relationship between the rough endoplasmic reticulum and the Golgi apparatus? There is a two-way street over here. We have proteins that move vesicles from the rough endoplasmic reticulum to the Golgi apparatus and back, okay? So what moves from the rough endoplasmic reticulum to the Golgi apparatus? This would be COP2. What moves from the Golgi to the rough endoplasmic reticulum? This would be COP1. Okay? So now that we've identified this particular aspect, let's see how this would be involved in our question. If we're talking about lysosomes are essentially organelles that aid in the destruction of proteins such as enzymes and things like that. It's not involved in the movement, it's involved in destruction of proteins. So this has nothing to do with lysosomes. Okay? Now, smooth versus rough endoplasmic reticulum. Whenever you hear of steroid hormones or cholesterol, you immediately think smooth endoplasmic reticulum. The smooth endoplasmic reticulum does not have ribosomes attached, hence why it is smooth. Okay? This relationship of this transport of vesicles occur between the rough endoplasmic and the Golgi. Now, if there is a defect in transport, there's more proteins that are that was my phone. There are more proteins accumulated within the rough endoplasmic reticulum. If there are more proteins here, this means that the rough endoplasmic reticulum gets larger. Okay, if that's the case, you would have a dilated rough endoplasmic reticulum. Okay, our answer would be D. Because C won't make sense because it's got nothing to do with the smooth endoplasmic reticulum, and it would not decrease the number of rough endoplasmic reticulum. Hope you guys enjoyed this video and stay tuned for more.